Introduction to Trigonometric Ratios. In this lesson, let us see how to find the value of theta or the missing side when a right angle triangle is given. So we also know that trigonometric ratios can be applied only if the given triangle is a right angle triangle. And now we shall see what are the different sides of a right angle triangle, that is hypotenuse, opposite and adjacent. How do you identify those, and then we shall proceed to how do you find the trigonometric ratios. So as I already mentioned, we need a right angle triangle if you want to find out the trigonometric ratios. So we are well aware that this is the right angle triangle, that means it is measuring 90 degree, and the side that is opposite to the right angle triangle will be always called as the hypotenuse. Now, when do we get the opposite or the adjacent side? In case there is the angle mentioned as theta, then the side that is opposite to the angle theta will be the opposite side, and the side on which the angle theta is resting is called as the base or the adjacent side of the right angle triangle. Depending upon the position where theta is placed, the uh, value of opposite adjacent keeps on changing. In case if I take the right angle triangle in this way, where this is the 90 degree angle mentioned, then for this triangle, this side will be called as the hypotenuse. Meanwhile, if this is the angle theta, then for this angle theta, this will be the opposite side. And since this is the hypotenuse and this is the side where theta is resting, this will be called as the adjacent side. If I say that my angle is theta for the same right angle triangle, then for this theta, this side will become the opposite side, and this is the side where the theta is resting, so I'll call it as adjacent side. So in order to make the difference, I mentioned different colors, so you can understand wherever the theta is, it gives the different uh, position for adjacent and opposite. So this is how you recognize the different sides in a right angle triangle. The three sides are hypotenuse, opposite and adjacent. We'll not look at the base, we'll try to remember it as adjacent side, the side on which the angle theta is resting. So in order to remember the trigonometric ratios, let's remember a small statement, that is SOHCAHTOA. So how does this give the relation? Let us remember that. So ka and to. So what is S? S is the first trigonometric ratio, that is the sine of any angle. Say our angle is theta, then sine theta will be represented as O by H. What is O? O is the opposite side and H stands for the hypotenuse. So this is the trigonometric ratio for sine of an angle. Suppose if you want the second one, that is cos of an angle theta. Yes, then that is A by H. What is A here? A is the adjacent side where H is the hypotenuse. Similarly, when we come to the third one, here, when we come to the third one, T stands for, sorry, when we say T stands for tan of the angle theta, that is defined as O by A, where O stands for opposite side and A stands for adjacent side. So this is how you can define trigonometric ratios, sine, cos and tan when you know the statement or the word, that is SOHCAHTOA, where the first alphabet S stands for sine, C stands for cos, T stands for tan, O and A and H are opposite, hypotenuse and adjacent. So if you're keeping this in mind, then it is easy to solve any kind of problems on trigonometric ratio.